Hey everyone, this lesson is going to talk about equations of lines, and this is just the first part in three parts here. All right, we've dealt with this a little bit already this year, this equation of a line that we use in this form, y equals mx plus b, all right? What we've talked about is that if we have an equation in this form, it's representing some scenario out there where we have this rate of change, right? This value is going to be some rate of change. And then this is often like our starting point with our scenarios sometimes. Graphically, it is the y-intercept of the graph, okay? So we're going to be writing equations of lines, and we're going to use this form, okay? We're going to find a slope, we're going to find an intercept, and then our input and our output will always stay part of that equation as well, and we'll have our equation of a line, okay? So let's start with, well, what if I'm just straight up given a slope and a y-intercept, if I'm just told what it is? Okay, well, my goal is to write the equation in this form, mx plus b. Okay, but my task is I need to find what these two values are. Okay, so I could think of it this way. I want y equals something times x, and then something at the end too, plus or minus something. And for this first problem, here's what that something is. My slope's 2, my y-intercept is -3. Bingo, I'm done. Okay. So number 2, my slope is 1/2, y-intercept is 3. Okay, well, then my equation must be y equals 1/2 x, and then plus 3. Simple as that, okay? So what about this one? Slope of 1, y-intercept of 2. All right, well, y equals 1x, and then plus 2, because my y-intercept is 2, okay? Now, one thing I'll change here, because you'll kind of rarely see the 1 in front of the x. Oftentimes, your equation just looks like that, because we assume there's a 1 there, so we don't write it. It just simplifies that equation a little bit. Either way is fine, though. If you like writing it, go for it. All right, last one here. So y equals, my slope is 8/3. That's weird. Whatever. 8/3 x, my y-intercept is 5. Bingo, I'm done. Okay, so if I can find those two things, I can write my equation. All right, that's what we're doing today. What we're going to start with is finding those two things if we're given a graph. Okay, so again, my task is to write y equals mx plus b. That's the line that's going to model this equation, all right, or model every single point on the line, and I need to find these two things. All right, well, I like to start with my y-intercept, actually. It's a nice point that we like to identify. We're going to need it. So in this case, my y-intercept is 2. So I'm going to just make note of that. B is 2. All right, and then I always move forward on my line. So I'm going to move forward on my line until I get to another point that's kind of crossing the grid. Kind of nice. You see that there? All right, and then I'm going to continue on. I like to do a couple if I can. And sure enough, I can. Okay, so my slope, and we've worked with this, is my rise over my run, right? So m is rise over run. We're always moving forward. So I'm going to start here, move to here. So what would I have to do first? I would need to go down 3. And then I could run forward, and I'm just running forward 1. So my slope is -3 over 1. Which is just -3. We could simplify it. So my equation for this graph, all right, the equation that represents that line is y equals -3x. My y-intercept was 2. Okay, bingo. This equation would generate every single point on this line. Okay, so I'll just try to convince you here. If I took an x value of 2, right, I would put that in. So I would say, okay, my x is 2. Let's see, -3 times 2 would be -6, plus 2 would be -4. So when x is 2, y should be -4, and sure enough, that gives me this point right here. Okay, every single point on this line would be created by this equation, right? That's the connection between the two, okay? All right, next one. Let's see. Start with my y-intercept again. It just so happens this one's 2 again. All right, so b is 2. And then my slope. So I'm going to move forward, and right there's a nice spot. I only got 2, so I'm just going to kind of double check back here. Yeah, I kind of like to highlight those, and I can see that it's a constant rate of change each time here. And what is that rate of change? Well, I'm going up 1 and over 4, right? I could start here too, same thing, up 1 and over 4. So my slope is 1 over 4, and that means my equation is 1/4 x plus 2. All right, a couple more now. These look a little weird. Now here's the deal. We do not use y equals mx plus b form for these two cases, right? The horizontal line and the vertical line. Here's the reason, because there's a simpler way to describe it. If I pick points on this line anywhere, oops, I missed there, but pretend I hit it. Anywhere on this line, they all have something in common. And what is that? Well, that y value of every single point on that line is 2. So if we just say, hey, y equals 2, that's going to give us this line, right? Because we really don't care what the x values are. You could pick any of them, and your y value is always going to be 2, because it horizontally is always at a level of 2, right? This one's really similar, except that if I kind of think about all the points on this line, anywhere, anywhere, both directions, forever, what do they have in common? Well, they have an x value in this case of -3, every single one. All right, so my equation is x equals -3. That's totally fine, and that's a good description of this line. Okay, there you go.